let's continue talking about torque. I told you in the last video that pivots are really important to torque, and the reason why is because changing where the pivot is actually changes all of the torque. So here I have a rod and it's on a pivot, and the pivot is more towards the left than it is to the right. If I add weights to each one, and I add them at varying degrees or distances from the pivot, then I'm going to increase. So as I increase the distance from the pivot, so increase distance from pivot, I'm actually whoa, increasing torque. Sorry about that. So increasing torque as I increase the distance from the pivot. Because remember again that our torque formula is force applied perpendicularly to a distance. And so the distance from the pivot point and the force of weight of the object in this case. The only tricky part about these, because this is still the net torque formula, we're still going to do the torque of M1 equals the torque of M2 plus M3, is that we actually have to figure out what the torque of the object being balanced is, because it also has a force of weight, and that force of weight is being applied from the center of the lever, not from the edge of the lever, not from where the pivot point is, but from the center of the lever. And that becomes very important, especially when the lever is not massless. Now, on many occasions, it's going to give you a problem where the lever is massless. In that case, you don't have to worry about it. You just go ahead and do your net torque formula. So here, you would also have to do the torque of the lever. Sometimes you're going to have swings, and the swings are a little bit trickier because it'll ask you about torque of a person sitting maybe more to the left. And so they'll ask you, the distance. So from here, you have to determine which pivot point you want and then use your net torque formula.